Hi there, and welcome to today's class. Let's proceed in the study of let's proceed with the study of probability. So let's look at yet another concept called probability of complementary events and sample space. First is first, I would like to do a recap of something. So let's say I have a die. Let's say I toss a die, right? So this is sample space for a die as usual. This is like the most common use example we do use to explain these things. So this is your die here, and the total sample space for a die is 6, as we have here. So given an event A to be this and event B to be this, before I move on to what we really mean by probability of complementary event, before we look at complementary event, let's do a recap there. We know before now that let's say we're asked to find A and B, right? Probability of A and B. So we're asked to find probability of event A and B. We know that this is also written as the probability of event A intersection event B. So your first priority there is to find what is A intersection B first before you find the probability. So A intersection B means what A and B has in common. So A and B has 3 and 4. You can see 3 and 4 in common. So A intersection B is just 3 and 4, right? So in the A intersection B is just 2, because 3 and 4, 1, 2, there are two possible outcomes from A intersection B. So the probability of A intersection B will be equal to what there? Equal to what? 2. Probability of intersection B is 2 all over what total outcome, which is 6. 2 over 6. In other words, the probability of A intersection B equal to what there? 1 over 3. This becomes your answer to A and B. Probability of A and B. Also, let's do quick revision on B. For question B, let's say I have probability of A or B. We said for A or B, first things first, proper probability, find A or B first. So A or B can also be written as what? A union B. And this is equal to, what's A union B? Combine A and B without repetition. That gives you 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is A union B. In other words, the probability of A or Miss union B will be equal to A union B is 1, 2, 3, 4, 5. 5 outcome of A union B all over total outcome. That's of course what there. Of course 6. So I put 6 here. My answer here is what? 5 over 6. This is what we have learned in our previous classes, how to find and or concept, right? Let's look at today's idea, which says probability of complementary event. So let's say I'm asked to find the probability of a complementary event. This is written as probability of a complement of event A. So let's say we're asked to find probability of complement of event A. So this symbol signifies complement of A. So your first tag is this. What is complement when it comes to set? We have done set before, and in set they ask complement. So let me just define what complement simply means. So if I want to find probability of something, I have to find that thing first. If I look at probability of that thing, so I'm asked for probability of this. I first find this first, right? Before I find probability. When I was asked to find probability of A and B, I first find A and B first as this, which is 2. If I now find probability. So let's find the probability. What's A complement? A complement means what? A complement simply means give me all the elements in the sample space, not in A. Now, A complement simply means write out all the members in sample space that is not in A. Now, 3 and 4, so that's not in A. If you know very well, so observe that 2, 3, 4, 1, 2, 3, 4 are in A, and 1, 2, 3, 4 are still in sample space. So write out the members that are in sample space, not in A. all the members in sample space not in event A. So that's 5 and 6. 5 and 6 are in the sample space but not in A. That is the meaning of what? Complement. Complement means write out all the elements in the what there in the sample space that is not in A. So 5 and 6 are in sample space but what? But not in A. That becomes what there? Complement of A. That's the space. So the probability becomes what there? The probability of A complement becomes what there? How many is here? That's 2. 2 over sample space is what? Is 6. That gives you 6. This one gives you 1 over 3. That is for this case. This is how to find the complement event, right? So let's say we are asked to find probability of A. So let's say we have to find probability of A alone. Probability of A alone is simple. The probability of A means we said number of possible outcome of that event. Event A, how many outcomes event A has? 4 outcome. That gives you 4 over what? 4 outcome. Over total outcome is 6. That gives you 2 over 3. So my answer, the probability of event A occurring is 2 over 3. Now, here is what I'm going. Right, this is what I'm going. This is the main focus here. How to find complementary angle, a complementary event. This is the main focus here, right? And I've shown how to get it. Complementary is got by writing out the members in sample space that is not in that event you are considering. That's how you get this one. Now, why I'm saying this is because why I say we should find the probability of event A to 3 over 3. If you observe something, if I had probability of completed event A plus probability of A, my answer should be 1. This is a principle that if you add the complement of an event plus probability of that same event, you have 1. Let's confirm this if this is true. Now, the probability of complement of A is 1 over 3. That's 1 over 3 plus the probability of A is 2 over 3. Add them up. This gives you 3 over 3 and this gives you 1. You can see that the sum of the complement of A plus the probability, the sum of the probability of complement of A plus probability of event A, that same A, is equal to what? There is equal to 1. As you can see, I have proven it that this one here is this. Add them together, you have 3, and that gives 3 over 3. That gives you 1. So in essence, if you have to find the probability of a completed event, don't stress yourself. Just take it from here that the probability of a completed event A is equal to what there? 1 minus probability of A. This formula you need to know. So if you are asked to find a complementary event of any probability, just do the probability of the completed event equal to what there? 1 minus what? Probability of A. So you just find the probability of A alone, and then you have your answer. As simple as that, right? So this is how the idea of complementary event of probability works, right? Let's take one example before we leave for today's class. So I'm saying this: instead of me going through this process to get probability of complement of A to be 1 over 3, I could go through this process. So just put 1 minus probability of A is just 2 over 3. So 1 minus 2 over 3 will automatically give you 1 over 3 as your answer. This is like the idea behind probability of complementary event and sample space. Let's take one example before we leave for today's class. One example before we leave for today's class. One example before we leave. Okay, example 1. Okay, example 1. It says example 1. All right. It says if the probability of a selected red marble in a bag full of marbles is 35%. What is the probability of selecting a marble that is not red? I said again, if the probability of selecting a red marble in a bag full of marbles is 35%, what is the probability of selecting a marble? What is the probability of selecting a marble that is not red? So what we do is this, please. We said they said in the question that listen, please. They said in the question that what's the probability of selecting a red marble? So it's 35%. So the probability of selecting a red marble in that question is what? 35%. And this means 35 over 100. So it means that the probability of selecting a red marble is equal to, divide these two, you have 0.35, if I'm correct. Alright, so we did now ask us that what then is the probability of selecting a marble that is not red? So that's mean that's complement. So you have to find probability of picking a red marble that is not what there, that is not red. The probability of selecting a marble that is not red. This is how it works, please. So I have to find probability of complement of R. We said to find it simple. The probability of a complementary event R is equal to what there? 1 minus what probability of that event R. And this is equal to 1 minus probability of R is 0.35. In other words, my final answer becomes 0.65. So 0.65 will automatically make it to be 65%. It becomes your answer to this particular question. This is a solved problem when it comes to complementary probability of complementary events, as simple as this. Alright, at this junction there, in our next class we'll look at the idea of conditional probability with Venn diagram and contingency table in our next class. If you found this class helpful, do well to share this video, leave a comment and subscribe to this channel. Also do well to invite your friends to our YouTube channel. Also check the video description. I always leave a link to our WhatsApp community and our WhatsApp groups and WhatsApp channel. So do well to join our WhatsApp channel, WhatsApp group. Also, I have my all social media handle, my Facebook page, TikTok, and YouTube page, all in the description. So follow us there, and we'll see you in the next class. Welcome to Excellent Link Academy. Okay.